We have all been there, staring at a screen, repeating the same facts over and over until they stick. It's a painful process, and usually, most of that information vanishes the second we look away. When early church builders wanted to create soaring ceilings to inspire their congregations, they essentially had two options. They could use clever engineering to support and distribute the weight, or they could simply build incredibly thick walls. Relying purely on repetition to grind information into someone's head is the mental equivalent of building those massive walls. Yes, it works eventually, but it takes an enormous amount of time and resources to force those facts into place. And worse, it forces the brain to retrieve that information in a strict sequence. You have to tick through an entire mental list just to find what you need. If you forget a single step in that chain, the rest of the information is inaccessible. Hammering data into our long-term storage this way is an incredibly inefficient design for human cognition. We need a smarter way to store and retrieve what we learn. The core issue with rote learning is that it tosses all those repeated facts onto a single mental shelf. Without any distinct context, your brain has only one narrow place to look when it tries to locate that data later. But human memory doesn't always struggle like this. There is a biological bypass called a flashbulb memory, where the brain records an entire event instantly and permanently, without needing a single repetition. When someone witnesses or even just hears about a major disaster, like a bridge collapse, they often remember where they were, what chair they were sitting in, and what the room looked like. The sensory details are burned in instantly. This happens because of biological prioritization. Remembering exactly how you escaped a deadly predator is a crucial survival skill. Your brain knows that forgetting a minor daily chore won't kill you, but forgetting how to deal with a bear absolutely will. This diagram shows an importance filter. Normally, it's highly selective, letting only a tiny drip of information into long-term memory. But in an emergency, that filter blows open. The brain assumes everything is critical to keeping you alive, capturing all surrounding data at once. Our memory systems aren't actually weak. They are simply highly optimized to reject boring data and immediately trap data that seems crucial to our survival. The problem for anyone designing a training program is that we obviously can't stage a life-threatening emergency just to get people to remember a new software update. Without that intense emotional trigger, the brain relies entirely on practice to physically wire new neural connections together. It works like walking across a grassy field. Walk the same route enough times, and you eventually wear a clear dirt path into the ground. But if you stop using it, that path eventually fades back into the wilderness. But there is a biological quirk here called habituation. To conserve energy, the human brain actively tunes out stimuli that are highly repetitive and unchanging. If a learning process relies solely on monotonous repetition, it signals the brain's defense mechanisms to ignore the exact information you want it to retain. This brings us to the clever engineering solution, consciously storing new information on multiple mental shelves. By applying the same facts in varied active contexts, you create multiple neural access points. Instead of relying on a fragile sequence of steps to recall something, you build a web of direct routes to that specific piece of data. This sketch illustrates one of the most effective tools for this: storytelling. Framing facts within a narrative bypasses the importance filter because it plugs the new information into mental frameworks the audience already understands and cares about. You can also use a technique called emotional matching. If the emotional state of the training aligns with the emotions a person will feel when actually doing the task in the real world, the brain retrieves the information much faster. You provide a variety of contexts, anchor facts inside a narrative, and mirror real-world emotional stakes. These steps ensure the data actually survives the brain's filters. Lasting retention isn't achieved by hammering facts into someone's head to build a thicker wall. It is achieved by engineering smarter, highly connected pathways so the brain actually wants to keep the information.